Well. Welcome to today's Yebo Tutor session. My name is James. I hope you guys can hear me loud and clear. Please just write something on the chat. Write something on the chat. Tell us how the audio is sounding to you. And just give us feedback. If you are connected, you can simply say hi. Would appreciate that very much. I hope you are not receiving feedback from your end, but I'm sure the sound should be good on your side. Okay, so we're gonna start. We're continuing from the last part where we're looking at projectile motion, and this is not so much of only projectile motion. Some questions that you would come across in your exams, in your tests, in your exercises will entail a combination of a different set of concepts. So right now we have this question which we're going to look at today. And from this question, we are going to apply what we've said so far about vertical projectiles. And we're also going to apply a bit of what we know about momentum. So in our previous sessions, we didn't talk much though about vectors. We did highlight or just point them out in passing. And importantly, vectors and scalars are quantities that we need to know and we need to define clearly so that when we deal with a number of these calculations, it helps us identify what kind of quantity we're dealing with so that we can present it accordingly. So understanding the type of quantity you're dealing with helps you even in the calculation. If you're dealing with a vector, then you know you should give either your answer in terms of magnitude and direction. Since there's a serious lag between my video and what is on the what is showing online. Okay, I don't know if I'll be able to fix this. Just give me a moment. I'll just try to do something so that in case I'll be able to just reduce on the lag, the delay between my voice and what you receive on the other end. So just give me a moment, just bear with me. I don't know if that will be possible. Okay, I don't know what that would do, but I'm sure, yeah, if ever it continues, I'm sure the sound and what I'll be showing on the screen will be coherent, so that shouldn't be much of a big problem. Okay, so let's get on with it. Let me just have the question and the screen. Okay, I'm sure that's all we need right now. So the question is the one that appears here. Is it saying ignore the effects of friction? I'm sure that should be from the previous part. Okay, so that's the start of the question. So the question goes, a girl on roller skates of combined mass 52 kg moves horizontally at a certain constant velocity. So take note of the keywords there. She catches a brick of mass 5 kg, which is thrown vertically downwards from the top of a high wall. The girl continues to move in a straight line at a speed of 2.4 meters per second after catching the brick. Okay, so this is all the information we are given, and we're also told to ignore the effects of friction. Right. So we have a few things to note there. So the first thing, if you are given a calculation as you are still thinking, trying to gather yourself together in terms of what is required, the given quantities are all you need to list down first. When you list them down in a manner which is not the same as the way they are given in the description or in the question, then you get to understand, you get to a point whereby even when you choose or select the appropriate equations, you know which quantities you have, which quantities you don't have, and that guides you accordingly. Okay, so this is what I mean. What we have so far is mass of girl and a combined mass of girl and the roller skates. So the mass, we'll call it M, and we'll just put should we put a G for girl or C for combined mass, right? Because you usually use mg for mass times gravity. So say M with subscript C for combined mass of girl and roller skates, and this mass is 52 kgs, okay, SI units, and moves horizontally at a certain constant velocity. So the initial velocity v1, we don't know what it is, we're not given, so already we know we have an unknown there. But she catches a 5 kg brick, which is thrown vertically downwards from the top of a high wall. Then the girl continues to move in a straight line at a speed of, so after she catches the brick, she has a velocity, we call it v2. So we've assumed that catching the brick, which is moving downwards, results in the girl moving with a new speed, with a new speed in the same direction. So I told that the girl continues to move in a straight line at a speed of 2.4 meters, 2.4 meters per second. Okay, after catching the brick. So this is, and the mass of the brick, mass of brick MB is 5 kilograms. So this is all the information. We're told to ignore the effects of friction. Okay, so guys, if you have any comments or you would like to call in via Zoom, the link is there for those that are on the WhatsApp chat group. You will find the link there. For those of you who are just joining us and are on the YouTube platform and are seeing from there, if you look at the QR code that is just above me to the top end of the screen, so between the Zoom logo and our Apple logo, you'll find there's a QR code which you can scan there. So if you scan that one, it will lead you to our Zoom platform where you can call in and you can talk directly with us. So feel free to do that. Feel free to interact with us. We would like to hear your views. We would like to hear your contributions or any points that you would have. So you can use the chat section on YouTube. If you want to type your text, you can use that chat section. We'll be able to interact with you or address the questions that you give to us. Great. So now our first question, the first part of this question. Write down the horizontal speed of the brick just before the girl catches it. Write down the horizontal speed of the brick just before the girl catches it. Okay, so we never talked about the speed of the brick. We talked about the speed of the girl here. The speed of the brick, this brick is thrown downwards, so the brick is falling. This is the brick falling down under gravity. So it has a velocity downwards. But the question is, what is the horizontal? Take note of the question there. Be careful. It requires us to find this horizontal velocity. The horizontal velocity. So for a brick moving downwards, the horizontal velocity is equal to 0 meters per second. It has no component either to the right or to the left of its motion. So the horizontal speed of the brick just before the girl catches it is 0 meters per second. Right, that should be simple. It should be very simple. We only have downward motion on the brick before the girl catches the brick. Now, the question goes on to say, calculate the girl's speed just before she catches the brick. Now, there it goes interesting. What is the girl's speed just before she catches the brick? What is V1? In other words, we call that V1. So we need to find V1. And now we're told that after she catches the brick, V2 is the combined velocity. So she catches the brick and the two are combined. The mass of the girl, the skates, and the brick is a total of 52 plus 5. But the combined, also the combined velocity is 2.4 meters per second. So this leads us to what we refer to as conservation of momentum. In a conservation of momentum setup, we have momentum being conserved, meaning the total initial momentum, so rate momentum is equal to the total final momentum. Okay, so the momentum before collision or before the brick and the girl are in contact should be the same as the total momentum after they are in contact. And this total initial momentum is the mass of the girl times velocity of the girl plus the mass of the brick times velocity, horizontal velocity of the brick. So this is linear momentum. Take note, this is linear momentum. So we're looking at it in one direction. So we'll consider the momentum in the x direction, which is the horizontal. So also it means the momentum in the, what can you say? The momentum in the y direction in the vertical should be conserved. It should also be conserved. So now for the horizontal, we have the mass of the girl, velocity of the girl plus mass of the brick times the initial velocity of the brick. Then the total final momentum is the mass of the girl plus the mass of the brick combined, moving at a velocity v2, which we call v2. Remember, we call v2 the combined velocity. So the total momentum there is mg times v2 plus mb times v2. They are both moving at a velocity v2. Okay, so that makes it a simple one to address because vh is 0, so we have 52. We'll substitute there times v1 plus 5 times 0 equals to 52 plus 5 times 2.4. Oh, my screen. What happened to my screen? Why is my screen not showing? Ooh, okay. What's happening with this screen? Oh, screen. tape cost. Okay. Okay. Okay, just hold on. Just bear with me a little. Just bear with me a little. Something is not going right there. Got it. Okay, great. I'll just go over what we were talking about again so that we are at the same wavelength. Okay. So this is what we were saying. So I just started here. It's not much that I'd written though. It's the mass of the girl, combined mass of girl and skates, 52 kgs. We listed this. And the velocity of the girl, we were not told, so we put a question mark there. We don't know that. This is what part 4.2 requires us to find. Then we are told that after the girl catches the brick, the combined velocity for the motion of the girl and the brick is 2.4 meters per second, and the mass of the brick being 5 kgs. So the first part of the question simply said, what is the velocity of the brick in the, or the horizontal speed of the brick? So which is the magnitude of the velocity in the x direction. So we said Vh for horizontal velocity, and we found that to be 0 because there is no component for a brick moving downwards. There is no component of velocity perpendicular to the direction of motion of the brick. So this velocity is 0 meters per second. Now the next part required us to find the girl's speed just before she caught the brick. And this speed, we said we find it by considering conservation of momentum, where the total initial momentum will be equal to the total final momentum, right? So by total initial momentum, we're saying the sum of the momenta for the girl and the brick, momentum being mass times velocity, and remember momentum is also a vector. So if they if we are to add them, we add them with their respective directions. So we cannot add something in the x with something in the y. We have to consider linear momentum, something in the x with the horizontal velocity which is in the x, right? So this is the linear direction of the two adding momentum. If it was at a certain angle, then that would mean the component of this motion along the x is what we consider. So it has to be linear. So for the x direction, the mass of the girl times the velocity v1, which we don't know and we need to find, plus the mass of the brick times the horizontal component of the velocity of the brick, should be equal to the mass of the combined, the girl and the brick, the combined mass of the girl and the brick times the velocity of the combined that combination. Now the mass of the girl, 52 kgs multiplied by V1 plus mass of brick multiplied by horizontal velocity or horizontal velocity of brick, yes, or horizontal speed of brick in the x direction if you want, should be equal to the combined mass of the brick and the girl, 52 plus 5, multiplied by the combined velocity of the brick and the girl. Now, what does that mean? We have 52 V1 plus 0 equals to 57 multiplied by 2.4. And that means V1 will be equal to 57 multiplied by 2.4 divided by, so we divide by 52 both sides, right? 52 over 52 and over 52. That's how we eliminate 52 on the left hand side, resulting in V1 being equal to that part. Okay, so you can calculate, tell us what you get. Do the calculation, tell us what you get for that calculation. I'll just do it on the screen. Will I be able to show this question screen? Okay, calculate, it's this one. 57 by 2.4, 50, okay. 57 multiplied by 2.4, everything divided by 52. Okay, 2.63. So we get 2.63 meters per second, and this makes a lot of sense. Why? Because the initial velocity of the girl is greater than the final velocity of the girl in the brick. The girl reduces speed from 2.63 to 2.4. I think I would take this one from that kind of reasoning. So at times you have to apply some reasoning in your answer. If you see you get 26 meters per second, then you should question the girl moving at 26 meters per second on skates. And just by catching a brick, the velocity to reduce to 2.4, it really doesn't make a lot of sense. And I'm sure 26 meters per second is also a lot for someone who's skating, right? So yeah, 2.63 meters per second is the velocity of the girl just before she catches that brick. So that's a simple giveaway, 4 marks there. That's 4 marks for that part of the question. Now, the question continues. The girl brick combination moving at 2.4 meters per second moves onto a rough surface. She comes to rest after moving 2 meters along the rough surface. Write down a pair of action-reaction forces acting while the girl catches the brick. So you've got action and reaction forces there. We can list a number of them while the girl catches the brick. So we've got a force due to the weight of the brick. Force due to weight of brick. Pt2 and force from force from the girl's hand. So the girl's hand balances the brick. As the brick lands on the girl's hand, the weight of the brick and the force from the girl's hand will counterbalance. That's action and reaction. So that's an action reaction pair of forces. Or we can talk of the force from the weight of the girl and the force of the earth on the girl. So the other one is the force from the weight of the girl and the reaction force from the ground or from the earth. So this is action and reaction. These are the pairs of action and reaction forces. Okay, I'm sure that's a simple 2 marks to collect there. Then the big one, calculate the magnitude of the net force exerted by the rough surface to bring the girl brick combination to a stop after 2 meters. Calculate the magnitude of the net force exerted by the rough surface to bring the girl brick combination to a stop after 2 meters. That's an interesting one, guys. What do you have to say? What do you have to say? Yes, Viscolite got 2.63 here and ready. Thanks, Viscolite. That's awesome. You did that calculation perfectly. And Sia, we can see the questions. Thank you, Sia. Thank you, Sia. I should, my calculator got carried away with the calculator. Thank you, Sia, for highlighting that. So there is this next part for what we were talking about, or what we're talking about right now. The part which goes the girl brick combination. Moving at 2.4 meters per second moves onto a rough surface. So after catching the brick, the girl and the brick combination meets a rough surface from the previous one, meaning in the previous one we were told to ignore effects of friction. That's why this girl was able to move at a constant speed throughout. But after catching the brick, the momentum conservation requires that the mass of the combined body, which is the girl and the brick, should move at a speed of 2.4 meters per second, which is less than the initial girl's velocity of 2.63, which Viscolite just gave us, right? So now this combination encounters a rough surface which spans for 2 meters. So like after 2 meters, the combination comes to rest. So the first part of that question was write down a pair of action and reaction forces acting while the girl catches the brick. So during the time she catches the brick, we can have the weight of the girl and the reaction from the force from the earth on the girl, right? The force on the girl from the earth, the force of the earth on the girl. Or it can be the weight of the brick and the force from the girl's hand as a reaction. Okay, so we are done with that. We're now looking at 4.4, which now says calculate the magnitude of the net force exerted by the rough surface to bring the girl brick combination to a stop after 2 meters. How do we deal with this one? Sia and Viscolite, you guys have been active so far. Will you continue, or can someone else come in and tell us how we deal with part 4.4? How do we deal with part 4.4? How do we deal with part 4.4? We want the net force that is exerted by the rough surface, which is in other words the frictional force on the girl brick combination. We are told they stop after 2 meters. So how do we relate this? How do we relate this to the motion of the girl and the brick? Initial velocity, we know. The initial velocity we know. So let me not give you too many clues and see if you guys can do justice to this one. What do you have to say, guys? Anyone joining us via Zoom? Do we have anyone on Zoom? Did someone decide to call in? Get to use all the platforms. Feel free. This is just learning and having fun at the same time. So let's hear from you guys. The effects of friction. So this is now combining with what we did in our previous sessions. We talked of motion, and we talked of the effects of friction on motion. Did I see a message? No. Not yet. Not yet. Not yet. So who's gonna give us the first suggestion? How do we solve this question? How do we solve this question? So for this part of the question, V1 is 2.4 meters per second. The mass, total mass of the girl and the brick, 57 kgs. So you have a 57 kg body, 52 plus 5, moving at that velocity, and it stops after 2 meters. The stopping distance, so S, to use S or X is equal to 2 meters. So how would you do this, guys? There are many ways of solving it. It's not like there's only one formula or one way you can solve this. So let's try and explore the two avenues that I think will be of interest in this case. We can use the energy, the kinetic energy. We can use the kinetic energy, and the work done should be equal to the work done by the force over that distance to stop this body, right? So the work done by the frictional force over the 2 meter distance to stop this body should be equal to the kinetic energy. So that's one way of dealing with it. The other way is finding the acceleration first, and after finding the acceleration, basically the deceleration over 2 meters, we can use that deceleration to find the force. Okay. So let's see if both methods will give us the answer, right? So in this case, we're saying half mv squared. The mass is the total mass, v is v1, should be equal to the frictional force times the displacement. Then this is half of 57 times 2.4 squared equals to the force of friction times 2 meters. So we divide by 2 and we divide by 2, we remain with 57 times 2.4 squared over 4 is equal to the frictional force. You can calculate that again and tell us what you get. So I'm gonna do the calculation also. 57 multiplied by 2.4 squared and close bracket, divide everything by 4. I'm getting 82.08. 82.08 is equal to the frictional force. Calculate the magnitude of the net force exerted by the rough surface. So that net force, the net or resultant force that resulting in acceleration or deceleration of this a girl brake system is equal to 82.08 newtons. Let's see the other method. If it gives us the same thing, we have displacement v squared equals to u squared plus 2as, so we know that s or x equals to v2 squared minus v1 squared over 2a. So a will be equal to this over 2s. So this is coming from this expression, x equals to v2 squared minus v1 squared. Actually, v2 squared is equal to v1 squared plus 2ax. v2 squared, the final velocity squared, equals to the initial velocity squared plus 2ax. So if we make a the subject, we've got v2 squared minus v1 squared over 2s or 2x. Okay, so don't worry the letters, I'm just trying to use the letters that you are familiar with. And my screen is frozen again. My screen is frozen again. Okay, so we said we have physical light got 82.08. Which method did you use? 82.08. Perfect. Which method did you use? So we listed the velocity of the brick and the girl, the total mass of the brick and the girl, and the distance they move before coming to a halt or to a stop, complete stop, to rest. And we said kinetic energy, the total, this is conservation of energy anyway. So energy is conserved, meaning the total initial energy is equal to the total final energy. So the kinetic energy in this case is equal to the work done. Is equal to the work done. By the frictional force. And our kinetic energy is half mv squared. Our kinetic energy being half mv squared. So we said kinetic energy there, half mv squared is equal to force times displacement, the frictional force over the displacement which the body moves until it comes to rest. And that kinetic energy is 57, the mass times 2.4 squared times 0.5. And if we divide by 2, both sides will come to a point whereby we find the frictional force is 82.08. So we are now using the other equation, which is v2 squared equals to v1 squared plus 2ax to find a. Because we know that the final velocity v2 equals to 0, v1 equals to 2.4, x is equal to 2 meters. So this is meters per second. And with all those parameters, it means A equals to 0 minus 2.4 squared over 2 times 2. And that acceleration is 2.4 squared negative 2.4 squared divided by 4. Minus 1.44 minus 1.44 meters per second squared. So it means this is the deceleration. This acceleration is in the direction opposite to the motion of the girl. It means the girl decelerates, and that is true because the girl and the brake both come to rest. So with that deceleration, the force causing the deceleration is also in the negative. So this force is negative. F is equal to m times a. This force is already in the negative direction. It's an opposing force. So with respect to the motion of the girl, we've already found that A is also in the negative. So we say F equals to minus MA, which is equal to negative 57 times minus 1.44. So this gives us the magnitude of that force. It simply gives us the magnitude of that force. They are in the same direction. So we can as well forget about that negative, remove that negative, because the force and the acceleration should come out in the same direction. So this is 57 times 1.44, 82.08. So this gives us negative 82.08 newtons. It means the frictional force is in the opposite direction as the motion of the girl and the brake. Or in other words, it means the frictional force is in the same direction as the acceleration. So we can look at it also in that way. So the magnitude of this frictional force is 82.08. It comes out to the same thing. It's in agreement with what we got there. So it's in agreement with what we got using the conservation of energy. Okay, so that's 5 marks for you by simply doing that. So I hope you guys were able to follow, and you guys can now calculate a question that combines the different principles that you learn in your physics. So this is all I have for you today. We'll look at more questions in our coming sessions. So watch out for this space. Subscribe if you haven't subscribed to our YouTube channel, so that you can always be notified whenever we go live. Otherwise, from me and everyone at the Yebo Tutor team, it's goodbye for now. Enjoy your weekend and all the best with your studies. Keep well, guys. Bye-bye.